Welcome. Our next speaker is Kosa Nenadic. She's a system architect at Ethernal in blockchain and enterprise system integration of Blade blockchain. Kosa will reveal how the Blade blockchain is shaping the future of enterprise blockchains by tackling the unique challenges of secure related access systems. Blade integrates seamlessly with AWS, ensuring top-tier security while meeting the demands of conservative enterprise environments. Welcome, Nenadic.
Thank you. Hello, everyone. My name is Kosa from Ethernal. Today, as said, I will talk about blockchain in enterprise systems. Specifically, I will talk about integration of Blade blockchain in an enterprise ecosystem. So, in this presentation, I will explain what are the key features of an enterprise software. I will explain what the enterprise identity management system is and how it relates to this topic. I will explain what the Blade blockchain is and give few details about this product from Ethernal. I will present a high-level architecture of our solution for integration. I will explain the key components of this integration, and in the end, I will give a few closing words stressing the most important things in the integration. So let's start with the key features of this enterprise software. So we can tell that there are many important key features, but here we have, let's say, presented 4 of these. The first one is enterprise level security compliance. We are aware that enterprise ecosystems follow a number of rules, policies, standards, especially industry standards, and those standards often have to be approved by some regulatory body or some authority, and very frequently those standards or application of those standards has to be certified by certain bodies. What does this security compliance mean in practice is that when you develop enterprise software, you have to follow security principles such as least privilege, separation of concerns, layered security such as defense in depth. When you build on software, you have to ensure that there are multiple layers of security embedded. And in practice, for data that are exchanged in the system, it means that the data has to be secured at rest, in transit, as well as in the memory. The second key feature is the enterprise identity management system. Why this system is important? Because it keeps information about the users of the system, and this information has to be kept secured. We have to take care about access rights, about the applications that are allowed users to do. At the same time, we have to allow users to seamlessly authenticate and be authorized in the system. And in the end, users have to have, let's say, easy user interface to interact with. So that software has to be very, very easy to use for end users. The next key feature is reliability. We expect that the enterprise software, especially blockchain technology, has to be reliable and available 24/7, especially for the blockchains. We don't want any failures, and we expect the high availability of such a system. And the last key feature is performance. We expect that the performance of the system is such that the users can execute their requests without any delays. The second and the fourth key features are important, but they are embedded in the software itself. For this integration to be explained, I will focus on the second key feature and the first feature, and I will present the solution that we have implemented that basically includes these features. And the few words about the enterprise identity management system. You have probably used at least one enterprise identity management system. There are examples here, such as Azure AD, Microsoft AD, Okta, Jump Cloud, Ping Identity, and others, Google Workspace. And everybody who worked at some company has used some of these or another ones. These enterprise identity management system, they manage and control user digital identities, access permissions, authentication, and authorization across an enterprise IT infrastructure. And usually these systems rely on third-party identity providers, as I mentioned, and they offer features like user identity management, access management, authentication and authorization, lifecycle management, federation and single sign-on, and directory services, audit and compliance. And these are often, this work is often basically outsourced to identity providers who are dedicated to develop and enhance all these offerings they have. On the other side, we have a Blade blockchain. This is Ethernal's product. We have released version 1 recently. This is basically a cutting-edge private blockchain platform which is designed with focus on enterprise systems and enterprise needs. It's essentially an Ethereum virtual machine chain which is offering typical features such as execution of smart contracts, supporting decentralized apps, issuing tokens, and we also have enhanced features including improved scalability, faster transaction processing, and free transactions when this is required. So on the one side, we have an enterprise system with enterprise identity management system. On the other hand, we have a Blade blockchain. So how can we integrate these two? In this figure, we can see a high-level diagram of architecture of the solution. I will explain key points of integration. This particular implementation is done on AWS. We can deploy our solution on multiple platforms. This is just one example integration here. So what do we have here? On the left side, we have a third-party identity provider where user identities are. On the other side, we have AWS where Blade blockchain is hosted. So how can we join these together? The first thing is to integrate somehow the users of enterprise ecosystem into AWS. For that purpose, we have used integration between third-party identity provider and AWS IAM Identity Center. IAM Identity Center is formerly known as AWS Single Sign-On. It's basically, its usage is to enable users access to applications hosted within AWS and to allow user access to AWS accounts. For that purpose, we can set permissions on users that are integrated into Identity Center. So the first key point is the integration between third-party identity provider and IAM Identity Center. I will say a few more words later on, but for this, in this moment, this is the first thing that is important for the integration. The second thing, once we have enterprise user identities in user directory group in AWS, we need somehow to assign users Blade blockchain identifiers. So basically, what is the thing that identifies users in the blockchain? It's basically a key pair, private key and the public key, and an Ethereum address. These are the identifiers for the user. So we have to somehow assign those identities their blockchain identifiers. And that's done here by the component that we have developed, which is a mapper between enterprise identity to the blockchain identifier. Result of this mapping is basically blockchain identifiers, which are hosted in key value database. In our case, this is it is a KMS where the keys are stored, and the metadata about the blockchain identifiers is stored in the level DB, basically key value database. Now that we have blockchain identifiers for our users present in AWS, securely stored in KMS, we now have to allow users to use the system. And for that purpose, we have developed Blade Enterprise Wallet. It can be any other web application that leverages blockchain technology, but in this particular case, we have a web app, Blade Enterprise Wallet, developed in React. Since we have the web app, and since we have a IAM Identity Center, which is an identity provider based on XAML technology, and XAML protocol is basically backend protocol for exchange of authorization and authentication information, we can't go directly from single page app to one XAML-based identity provider. We need something in between. We need a broker IDP, which is suitable for web apps. Basically, we need to use a different protocol. We need to use OpenID Connect protocol to exchange authentication and authorization data. For that purpose, we have used AWS Cognito, which is also identity provider, but this provider is OpenID Connect-based provider. So in our case, we are basically integrating front-end web apps with the AWS Cognito, and then we are integrating AWS Cognito with the IAM Identity Center. In this way, the users can use single sign-on, reusing their credentials from third-party identity provider in our system. So basically, we do not host their credentials anywhere in this system, but we are using protocols, OpenID Connect and XAML to get their credentials from the external system. Now that we have blockchain identifiers in KMS, we have apps that are capable of reusing authentication and authorization from a third-party provider. Now it's time to enable these web apps to use blockchain technology and the user blockchain data. For that purpose, we have developed Transaction Coordinator, which is component in the charge of basically preparing transactions, signing transactions, and sending transactions on behalf of the end user. Those created transactions are signed and sent to our Blade blockchain, where the further verification and application of the transaction is done. So this is in short how the system is integrated and how it works. And here are these key points stressed once again. So the first thing was to integrate IAM Identity Center with a third-party identity provider. The second was the mapping between identities and blockchain identifiers. The third thing is integration of AWS Cognito with Identity Center. And the fourth is basically web application that is integrated with Cognito. And the fifth thing is Transaction Coordinator between web apps and the Blade. As I said, the first integration that I mentioned, we import and synchronize users in user directory within AWS. We basically exchange and save user attributes and the group information. We don't save credentials or any other security information about the users, but just user attributes and group information. In that sense, everything that is related to authentication is basically federated back to third-party provider. In this way, we have all enterprise identities available, so we can access them in order to assign them blockchain identifiers. It's important to say that import is done once, while synchronization is done in a timely manner. So every time something is changed on the third-party side, that change will be reflected in AWS. Here is the sequence diagram of the mapper component. These are a few more details about how mapper works. In essence, it fetches all enterprise user identities from user directory, and for each user, we create a key pair, which is kept in AWS KMS. It is important to say that the KMS is using hardware security modules in the background, meaning that the private key never leaves KMS, while public key can be exported. And that exported private key is used to generate Ethereum address. And all cryptographic work is essentially done within the KMS without leaving it. I could say also that KMS, as it's using hardware security modules, is basically managed by AWS. In that case, we cannot retrieve private keys. But there is also another option with AWS KMS. It is a cloud HSM solution, in which case AWS is not the one that manages keys, but the owner of the system is the one who is in charge of taking care of keys and cloud hardware security modules. That is also an option. It's certainly, it's not the cheap option. It's quite expensive, but for the companies who want to have more, let's say, work on the private keys and more control of it, they can use that approach as well. And now that we have keys stored in KMS, we are able to export the public key and generate address, and together with the user attributes and these information like key ID and Ethereum address, we can store user blockchain data in a key value database. I mentioned that integration of Cognito with Identity Center. Basically, we are using Cognito as a broker IDP. This is typical solution when you have a single page app, in our case React app, which wants to use information from XAML identity provider. We can't go directly. We need something like some kind of broker IDP in between, and this is in our case AWS Cognito. It could be any other OpenID Connect based identity provider, but since we are on AWS platform, we choose to use these. The thing is that initially we exchange OpenID requests and responses with Cognito, and from Cognito to Identity Center, we are using XAML. As for the single-page apps and the Cognito integration, there are two things that have to be done. The first thing is to configure application on the Cognito itself. And the second one is to enable use of the OpenID Connect protocol on the application side. In our case, we are using AWS Amplify client library, which supports different AWS services, and in this particular case, it supports Cognito. The fifth and let's say glue component of this integration is transaction coordinator. This component is in charge of preparing transactions, signing transactions, and the sending transactions between Blade Enterprise Wallet, basically any single-page app that leverages this technology, and the Blade nodes. And how it works in the practice, here is a bit detailed diagram about this this component. So what we have here is that we have a enterprise user, signed in enterprise user, which creates some transaction data in the application. User submits the data, sends it, the transaction coordinator accepts the transaction data, and since we have transaction data, but we don't have user blockchain identifiers like Ethereum address and key ID, we need to get those for the user. And how we do that is that from the access token, which is exchanged using OpenID Connect, we get this access token, which is basically JWT token. It's used to get user email from Cognito, and based on email, we get user data from a key value database. Now that we have transaction data, user blockchain data, we need some additional data to prepare transaction, which is transaction parameters taken from the blade. Once we have these, we can prepare transaction, we can sign that transaction. This is the process that happens in KMS, basically the part where we sign transaction digest is done in the KMS. And once we have a signed digest, we can create a signed transaction. This transaction is then checked for its validity by the transaction coordinator. And if that transaction is valid, basically it's sent to the blade. If not, it's invalid and we have an error. But if everything goes well, then transaction is verified and applied in the blade blockchain. The results are returned back to the application so user can see if transaction failed or it was successful. So with these 5 integration points, we have explained how this integration between an enterprise system and blade blockchain can work. This proposed architecture basically relies on existing enterprise identity management system. It allows users to keep their credentials while the blade takes care about assigning blockchain identifiers to end users. Basically, we saw that we have assigned user a key pair and Ethereum address. In this way, we have enabled transition from Web 2 to Web 3 because Web 2 is known for credentials that are used as an authentication mechanism. Now, our users, beside their existing credentials, have a blockchain identifiers as well, which are the features of Web 3, and now they can basically seamlessly use blockchain technology while still being within an enterprise. In this way, we have a blockchain technology which can be adapted by enterprise without disruptions in their existing operations. So that was the main goal, to enable users to use blockchain technology without having any disturbance in the process. So this is what I have for this presentation, and now it's time for questions, if there are any.
Are there any questions from the audience? Thank you, Kosa.
Okay, thank you.